Hey guys, welcome back to the 28th episode of Let's Play Space Engineers as a German engineer. I'm Daniel, I've been born and raised in Germany, and I've been living and working as a software engineer in the San Francisco Bay Area, Silicon Valley, for the last 10 or so years. Last episode, we built a dashboard synchronization script that we're making use of nicely up here with our dashboards that we're syncing from the different kind of like outposts that we have to our main base. This time around, I want to do some more classic building. I want to build a 3D printer. So specifically, as we continue to expand, we will want to build more ships and drones and possibly even more mobile mining rigs. And we need all of that stuff, but we don't really want to spend all the time manually crafting it. And this is where a 3D printer comes in and like will help us to kind of like accelerate this process. So it's investing in infrastructure so that we have an easier time moving forward, basically. And then the other thing that I have on this list here is adding a remote control block to the MMR, but that's just a minor point. The main thing that I want to do today is building the 3D printer. One thing I want to point out, we are running a little bit low on cobalt. We only have 1,000 ingots left, but I think the build that I'm planning for the 3D printer is not cobalt intensive. In fact, it barely uses any. So I think we should be fine with this. So I'm not going to rush with moving the MMR right now. That will take some time, and I don't want to spend that right now. I want to rather spend that on building the 3D printer, because that's going to be a big undertaking. So I think I want to build it over here, where we originally built the MMR. A couple things about the 3D printer. So the 3D printer will be big. In fact, I want it to be big enough so that it can print more MMRs. I'm not entirely sure how much use we will get out of that specifically, because I think 1 or maybe 2 MMRs will probably be enough to sustain our use of material. But you never know, especially once we have the printer and we start printing more and more stuff. That'll chew through a lot of material rather quickly. So maybe we'll need more. And then but if we have a large enough printer, then we can utilize that to print more. So the printer is supposed to be, or the printer will be large enough so that we can print an MMR. Now, I thought about how to build this 3D printer for a while. I had a couple of thoughts and ideas, and I also tried to find some inspiration online. So a lot of you guys are probably familiar with the most common form of a 3D printer, which is a printer wall. Right, so you take basically a bunch of welders. Let me see if I have a welder here somewhere. And you just stick them next to each other, roughly like this. And you build it as large as you want to build your craft in the end. And then you have an arm with a projector that you just pull the craft that you want to construct through this welder wall with. And it will print that craft. And that works, and that's awesome. However, if you think about the size of a 3D printer we will need to actually print an MMR, and granted, the MMR is mostly dead space, right? It's just a frame, and there's not much in the center, but the large frame requires a large printer. And so if we wanted to be able to build a print wall like this, to build this printer, we'd need a gigantic surface area of welders. And I don't think that is very economical or makes a lot of sense. So I don't think this is a good approach. Now, another approach that I've seen that people use is a rotary printer. For a rotary printer, you have a pillar somewhere like this. Somewhere stuck on that, you have an advanced rotor up here. And then you have a bunch of welders kind of sticking out like this. And now, if you rotate this rotor, it will rotate this stick of welders. And if it rotates the stick of welders, then you can just pull out again a ship through the stick, essentially. And if you pull it out slowly enough, it will weld it all up. So something like this is significantly better in terms of resource usage than a simple welder wall. But I also don't like it. So, I don't know if I mentioned this before, but I actually own a 3D printer, an old cheap Reality CR10. And the way that these 3D printers work, they have a frame similar to the frame of the MMR. And then they have pillars go up like this, right? Just like the MMR over there. And it goes across on the top here. And obviously that frame is there to give the whole thing stability, but it does something else as well. So within this frame, it moves around an arm, essentially a printhead. So you can think of the printhead as the welder, right? And it will move this welder around, and it'll start. It'll be low first, and it will move across the surface and print whatever it needs to print on the first layer, and then it steps up using a stepper motor that is ultimately connected. There's like a stepper motor for each of the 3 directions, and it will lift the head up and then print the next layer. And so it will print each layer, one layer at a time, using just a single extruder, like a printhead. I thought about this, and I do think an approach like this makes a lot of sense. There are a couple of twists, though, or like kind of like changes I think that one would need to do to this model to make it actually work in Space Engineers. So ultimately, I think there's 2 ways how one could move this printhead around. The first one that we've been using for some of our other builds, right, is a piston. So we could put a piston here, attach the printhead, and then we can move it back and forth. Now, obviously, if we want a printer that is large enough to print something like the MMR, we'd need a lot of pistons in succession, right? So each piston can push its head out 10 meters, right? So each piston will add an effective 10-meter range, and then that's 4 blocks. If I had to quickly guess, I don't remember exactly how many blocks it is, but it's like more than 20. Would need more than 20, certainly. And so it's going to be big and ugly, right? We're either going to have these pistons stick out for like a very far out of the printer, or we'll need to do the snaky thing where the pistons are basically next to each other but can push each other forward, right? By having conveyors, like do like these snake loops or whatever you want to call them. That's ugly. It's big. I don't like it. And also, that's not really how 3D printers in reality work. Or at least not most. There is an argument to be made that in the Z-axis, a lot of 3D printers use something similar to pistons, which is a screw. So they have a metal rod that has what is it called? The kind of engraving of a screw in it, and a stepper motor turns that metal rod to move the printhead up and down. But for the horizontal axes, 3D printers actually use a guided rail system. And I think that is also what I would like to use for our printer. In our case, we would want to have a set of wheels above and a set of wheels below, and then a set of wheels on the side as well to keep the printhead kind of like aligned along the rail in each direction. And if you're familiar with more advanced Space Engineer builds, then you might recognize that this is very similar to how a rotor wheel elevator works. And this is actually something I came across researching how to build this. So a rotor wheel elevator, what is that? Basically, it's an elevator system that instead of using the probably most obvious way to build an elevator, which would be a piston to push something up and down, it uses wheels and rotors to raise and lower a platform along a rail. The idea here is that, and I'm going to try to demonstrate this here. So the idea is you place rotors in these positions. So you have these rotors, and then what you do is you take off the heads, these large rotor heads, and you replace them with small rotor heads. And then what you can do is we'll grab some wheels. And we'll take the 5x5 wheels and we'll just stick them on here. So these are small grid wheels because I'm attaching them to these small grid rotors. What they will do is they will very nicely hug this pillar in the center. And then with these rotors turned on and obviously everything detached from the ground and whatnot, these wheels will be able to lift this platform up and basically crawl up this pillar. Let me weld this quickly up and then I can show you what I mean, just so that you have a better idea. Okay, I'm not entirely sure what just happened, but I was expanding this a little bit. One set of wheels is not going to be enough. It's gonna start kind of wiggling around. You need at least a second set of wheels, and they just popped off. I guess I had technically separated the pillar from the other static grid. I haven't detached it from the ground, so it's still sunk in the ground. Should still be a static grid. I'm not quite sure why they all popped off. But I guess I have to. Whoa. And they seem to be not having any gravity. And there's no sound. Okay, let me reload the game. I don't know what happened. This seems weird. Okay, I reloaded the game. Let's see if I can... Head is detached. At small head? Okay, it's just floating away. What is going on? Okay, let me rebuild this, I guess. I hope this is not a sign of worse things to come. I'm pretty sure this happened with all of them because I had like all these wheels suddenly in my face. They seem to be floating around, yeah. I guess the physics engine kind of lost track of these rotors somehow. Don't ask me what happened. I don't know what happened. Okay, let me finish putting this together and then get back to you. Okay, this is all welded up. It's still connected, so it's and I still need to configure the rotors here before I disconnect it, I think. But before we do that, I keep running out of energy here. I want to put and I keep running inside to the medical bay. I think I just want to slap one out here, so I have one easily accessible. So let me quickly do this. And I'm actually not 100% sure what this what it uses the conveyor port for. I think I want to connect it. I can't disconnect this without everything falling apart, though. That's fine, I don't need to see it anymore. Okay. Turns out it refills my hydrogen. Nice. Sadly not my hydrogen bottle, I still have to manually refill that. Cool. let's see here. We need to configure the rotor. So we're gonna set these to a velocity of 1 RPM. And then nothing happens. Oh wait, I know why. There's no power. Right, so I will need a battery. Okay, as you can see, this one is not turning. And it's turning in the right direction. If you, depending on how you install these rotors, you may have to set a negative velocity. I want to change a couple things quickly on this rotor, a couple settings. I want to add a braking torque. And I want 33.6. Can I use the M for million here as well? Or no, I cannot. Okay, then I guess I need to type that out. There we go. And the rest looks okay. I'm just gonna copy these. So in Build Vision, to copy, you hit the insert button and then page up. Now I can paste this onto any other. So I hit Control to open up Build Vision for this rotor, and then page down to paste. And it's active. And I'm gonna do this for all the other ones as well. The reason why nothing is moving yet is actually because right now the thing that we're standing on is still a static grid. As soon as we change this, okay, now all the rotors are rotating. So I'm gonna put this all into a group. Now I will change this grid here to be a ship. And that should, fingers crossed, detach it and make it go up. Okay. It's a little shaky. So far it's not really moving. Can I turn these off? And turn them back on? There we go. Now it's going. As you can tell now, it's not perfect. It's slipping occasionally. And I'm not 100% sure what is causing this. I think maybe these rotors are too close together. Maybe they don't have enough lifting power. So I think that when I messed with this before, I had them set up a little bit different. So maybe that's now coming back to bite me. Okay, let me add some more wheels just so that this works actually like I expected it to. I'm pretty sure if I add another set of rotors, like on top here, it will work. Only other difference I just realized as well is I built all these wheels in the same direction. And what I mean with that is they're all turning clockwise. I'm pretty sure in my last experiment I had them differently. Some were turning clockwise, some were turning counterclockwise. So I'm pretty sure I had... Okay. At a higher velocity, it seems to be working much better. Maybe that was just it. They were turning too slow. So it couldn't compensate for any minor slips it would run into. Okay, this took longer than I wanted it to. I wanted to just build a quick demo, and I've spent like over an hour on this. But here's the deal. This is now essentially a rotor wheel elevator, right? We can turn on the rotors, and if we reverse them, this will lift us up, and we'll block here. The wheels can't protrude past this. And then if we reverse it back, it will go down. And we can turn them off. We have the braking force up, so we can turn them off, and it will just... Well, I was going to say it will just stay there, but clearly that is not the case. All these wheels are touching this bar on the same side, so I wonder if that's has to do with it. In either case, I'm confident that a bigger version of this will work, and I kind of regret already saying that. Because typically things work worse when you scale them up, not better. But I had it working. Just rotor lock it. Will it also slip down? Oh, they are just turning through the rotor lock. Oops! Yeah, don't turn on train inertia sensors. Bad idea. Okay. Well, we'll learn that lesson. Okay, the point I was trying to make, however, this is essentially how a 3D printer works. It uses wheels to drive along rails. So the benefit of this compared to pistons is you can have arbitrarily long rails, and as long as you have the movement piece in place, you can drive along the entire rail without limitations. Whereas with pistons, if you want to go a longer distance, you need to build more pistons. And with a rail, the only thing that you need to do if you want to go a longer distance is build a longer rail. Now, there are some considerations. The rail itself, or at least this rail here, and the main rails of a 3D printer would be part of the actual static grid. But the components moving along the rails, and we would have, at the very least, two rail systems. We would have a vertical rail system, and then we would have a horizontal rail system. The components basically riding along those rail systems, they are not static grids, and they are not attached to the main static grid. And so this creates an issue, and you were kind of able to see this here somewhat. We had to attach a battery, and not only do we have to attach a battery because this thing here is not attached to our main grid, but even if this was attached to the main grid, because this thing up here is actually a ship, technically, a large grid ship, that just kind of like rides along the pillar, it needs its own power source. And the same is true for if this here were if this thing would lift up a horizontal rail, that then another kind of like crawler would crawl along, that would itself again be like a large grid ship riding along another large grid ship, which is riding along a static grid. That is fundamentally not a problem, but again, that second large grid ship, the second dimension kind of crawler, would have to have its own power source again. And then lastly, and this is where this whole thing I at first thought would be impossible to build. Because if we now put a welder onto these movable crawler pieces, the kind of, what do you want to call them? Sliders, right? That slide along the rails, or that crawl along the rails. How do you get material to that welder? Now, you could put cargo containers onto the print head essentially, and you could fill them up with material before you start to print. And you could build, you could have connector points along the rails that allow these large grid ships to connect to refill these containers using sorter blocks and other approaches. And all of that would be fine in theory, but I think in practice it will be incredibly hard to manage. And having the cargo containers on those printers, on these print heads here, would cause them to be loaded in different ways and could create kind of like imbalances and whatnot that may make them clang more or whatever. Like, there's just a whole bunch of problems with trying to put the print head onto these movable pieces. There is, however, so at first I thought, damn it, this is not gonna work. We'll need to figure out something else. But then I realized, wait a second. What if we put the welders on the static grid on the bottom, and we'll just put the projector onto the movable pieces. We won't need any material. We'll still need a little bit of power. We'll need a battery, and we need the ability to recharge those batteries, both for turning the rotors as well as for running the projector. And in fact, we'll also need some sensors, but I'll get to that later. But these batteries, these rotors don't need a lot of power. The projector doesn't need a lot of power. The sensors don't need a lot of power. So we can put some batteries on there, and then after every print, these movable pieces, they just dock to recharge the batteries. But it solves the material problem, right? Which was the big problem. The welders on the bottom, they can just be hooked up statically, like through conveyors, to the main base inventory. I was debating if I should use a line of welders or just a single welder, or just like a couple of small welders in the center. And I think I'm going to go with the line. While I will need to build a bunch more welders, it does significantly reduce the complexity of the printer. So the print heads, the welders go on the bottom. The way that I want to build what are essentially rotor lifts is I want to have 4 pillars on each corner. There's going to be a pillar. And then I'm going to have one big frame around those pillars, which will include the wheels. And I will make sure that I attach the wheels from both sides. So they're not all going to be turning clockwise. Some of them are going to turn counterclockwise, because I think this may make this more reliable. And then the frame itself will have another crossbar that is going to be perpendicular to the welders on the floor. So you can think, like, if the welders are going along this direction here, then the crossbar will come this direction, and then we'll have another suspension hanging from this crossbar, which will then roll essentially a projector along this direction. So we can then, with these suspensions on each of these 4 pillars, lift it up and down, and then with the suspension of this crossbar, move the projector back and forth. There are a couple more gotchas, in particular because these are independent grids and independent ships, these components. We can't just easily remote control them. So meaning we can't just have a button that we can push to kind of, for example, reverse the direction of these rotors. So we'll need to do a lot of this indirectly. And the way that I think we are going to do this is with sensors. So for example, as the printer goes across once, we'll have a sensor on the vertical grid that detects that the printer has reached the other side, and then cause the vertical grid to roll up one step. So that's the idea. to use sensors to keep basically the control of the rotors local to the grids. You can use remote control blocks and kind of like remotely quote unquote log into these grids to control them manually and things like that, but buttons will not work, which is sad actually. Like you cannot have a button that sends a command to a block across antennas. We could write some scripts to do this, but I would love for this to work like completely vanilla without scripts, and I think we can do it. So, and especially once we get the event controller in the next update, oh, that'll make so many things so much easier. Okay, let's get rid of these. I'll quickly break these down, and then we'll start putting together the 3D printer. Okay, we cleaned this up. I am going to quickly see how large of a grid we need. Let's quickly go and count how big the MMR is. So our grid needs to have enough space to fit 31 blocks in each direction into it. I think the MMR is a square. I'm actually not 100% sure, but we'll build it a little bit bigger than 31. So let's say 40-ish. So let's quickly just run some blocks out here for alignment purposes. Say we're gonna start a little bit out, so there's a little bit space here. 1, 2, 3, 4, 5. Okay, so the basic building blocks are in place. This is obviously not done beyond the welding up. There's more stuff that needs to happen here, but the fundamental building blocks are in place. Once this is welded up and these connection points that are still in place severed, right? Here's one that connects the horizontal bar to the vertical rig, And then there's a connection point here that connects the vertical rig to the static rig. And once it's all welded up and they're severed, these should be able to go up and down and back and forth independently. The parts of the printer. However, I am dreading having to weld all of this up. I guess I still need to remove the helper block that I added for just counting in 10 increments. But yeah, so I think I'm gonna do something which I should have done already before building the MMR. I'm gonna put together a small weld chip that I can load up material in, and I'll just go around and weld this all up. I think this will speed up the process significantly, and I should have probably done a long time ago. So let me put together a small weld chip of some sorts that I can use to weld this here up more effectively. Let's go. Okay, it's flying. It's not beautiful, but it will do, I hope. Let's see here. Okay. Whoa. Okay. Yeah, I've oversized it significantly because I expect it to... Oh, I need to put the connector on. I forgot the connector. I put 2 cargo containers on here so that we can load up a bunch of material. Yeah, but as I said, it's not beautiful, but I hope it will get the job done. This is the first welding ship I ever built, so hooray me! So, it's almost fully charged. I added 2 more batteries because the 4 thrusters that I have were exhausting the 2 batteries. Each thruster uses 2.4 megawatts. Each battery can deliver 4 thrusters is, what, 9.2 megawatts or something like that? No, 9.6. 9.6. So we need at least 3 batteries. I added a 4th one. Also, I loaded it up with steel plate. I think the second cargo container is overkill. If I load up 1 cargo container with steel plate, this is at capacity, basically, how much it can lift. But yeah, other components might be a little bit lighter, so I'll leave it like this for now. I'm not gonna take that 1 cargo container off again. Yeah. Then let's get to welding. So I have welded up the rails. The 4 corner rails are welded up. They still have the placeholder plugs that I need to grind off. And I've welded up the horizontal rails. I have not welded up the frame, most of the frame. I'm not 100% sure if I will. It's not really necessary, and I might just remove it instead of welding it up. I'll see. I'll figure it out. I'll think about it a little bit more. The other part I haven't welded up yet is this crossbeam here that connects these two crawlers, whatever, connectors. The main reason I haven't welded this up yet is because I'm not 100% sure it's at the right height. So I will need to install a projector underneath here. And the small grid projector will need a rotor with a small grid head. And then at the lowest setting, this should be still above this line of welders. And so I wanted to double check if this is at the right height or not, which I will do in just a second. The other thing that I need to do is I've welded up all the rotors and the small grid heads, but I need to attach wheels and weld those up. Which together with figuring out at which height this bar here is and welding that up is going to be my next step. So yeah, let me quickly see about the height here. This should be pretty straightforward. All I need to do here is throw on a rotor, remove this here, put on a small head, and then a projector. And I think, so the height of this here is 2 above this line. So 1, 2. This is where the welders will be. And so I think this should be above, but it's really close. But I think that's fine. Yeah, I think this is fine. Okay, then I will weld this bar up at the height it is at. And attach the wheels and weld those up as well. Okay, see you in a couple of minutes. So we got all the wheels welded up. We got some battery, an additional battery. We got this crossbar welded up. All the pillars, all the rails. We have removed the little knobs that I used to count blocks. Just to be clear, these up here, they're there on purpose. They are just so that this thing doesn't lift above that point. There's two more things that we need to do before we can give this a test run. We need to go and configure all these pistons. That means some of these pistons will have to run positively. So these pistons here I've already messed around with. As you can see, they are turning, well, technically counterclockwise, right? Because this is the front, right? And they're turning counterclockwise to lift up. So as you can see, these wheels are turning. If you imagine this was all disconnected and ready to go, this would pull this up. So these pistons over here, sorry, not pistons, rotors, to have the same lift effect, they will have to run clockwise, right? So, meaning a positive velocity. Okay? But these here, negative. So I need to go, find all the go to all the pistons, and then apply the right settings to them. Also, I want to apply the right names. I think I already called these printer vertical rotors. Yeah, and these are printer... No, this is rotor 91. Horizontal rotors. Yeah, some of them I've named, some of them I haven't. I want to give them all the right names and the right direction. And then I need to create two groups. One that contains all the positive, as in clockwise turning rotors, and all the counterclockwise turning rotors. So that if I ever want to adjust the speed at which this runs, I can use those groups easily. And then once I've created those groups and configured all the rotors, we're ready to disconnect. We'll disconnect this here, which will free this bar, and this bar should be able to roll across and back and forth. And then we will disconnect this, which will free the square frame here. And then the square frame should be able to lift up and down. That's the theory, at least. Let me configure the rotors, and then I'll get back to you to actually do the disconnecting. Oh yeah, I put blast door blocks here so that these wheels would not kind of collide with these blocks here. I did that on all sides where wheels are basically bumping up against the frame. Okay, then let me configure the wheels, or the rotors more precisely. Okay, all the rotors are configured, renamed, grouped. Everything is put together. So, let's give it a shot. The moment I sever this should start rolling, in theory. Oh. Oh, I okay, this was very anticlimactic. The moment I severed this, I also took batteries from it. So let's quickly fix that. The second I welded this up, it started rolling. Look at this. Slowly but surely, exactly like we wanted. Nice, I'll get the other one quickly as well. Okay, as you can see, this here is working great, in fact. I love it. But this was the easy part. The other one is the one that makes me a little bit, I'm a little bit unsure about. If we want to increase the speed, we simply turn them off first. We should set a braking torque. And now we can adjust the speed. Let's say 3 rounds per minute. And these here, we do -3 rounds. And then we'll turn them back on again. And now it should move quicker. Yeah. The next one, the one that makes me a little bit nervous, is this one. So, let's do it. It is disconnected. It's doing the same kind of lift a little bit and then slide down again. Oh no, no, it's lifting, it's lifting. Okay, it is lifting slowly. Oh, there it slid. I hope it doesn't slide too much. Let's set a braking torque. There we go. That is better. Okay, then turn it back on. Let's increase the speed. Actually, I will need to do this one at a time to increase their speed. So velocity, let's put them to 5. I think that was a value that worked reasonably well. And -5. And let's turn them all back on again. There you go. Well, this is what I meant earlier. So to control these, I can't actually do this from this control seat. They're not on here. What I could do is put an antenna here so that I can select the subgrid through a remote access. I can just go in here and then reverse them and then turn them back on, and now this will go the other way. Obviously, this is not done. Obviously, we'll need a projector here, which is a minor thing. We'll need the welding wall down here, which is a less than minor thing, but with our welding ship, should be quick and easy to do. In fact, maybe the welders can just weld themselves up, frankly. They probably can, yeah. But even with those two things, to make this printer actually work well, we will need to... So right now, we don't have a really controlled way to raise the printer in the vertical axis, or a really controlled way to move it in the horizontal. Moving into horizontal is pretty straightforward. Basically, you just let it run across. But in the vertical axis, we need stops, meaning, or steps, meaning we need to raise it up a little bit, and then we need to stop it and let the horizontal arm do its thing. And then once the horizontal arm is done, we need to raise it more, and then the horizontal arm needs to come back, and so forth. I have an idea how to do the stops, but we spent quite a bit of time on this here already, and I think we may have to finish it next time. So I just walked to the dashboard, and I notice I'm still losing eyes when I walk through the doors into the pressurized area. I've set up this oxygen tank here, and there is a vent. There's a vent right here, which is set to depressurize. This should pump oxygen, and I mean, the oxygen tank, frankly, is full. But I feel like what happens is it's not pulling oxygen. It's pulling oxygen probably from the oxygen tank, but then it refills it from the H2 generator instead of from using the outdoor vent. Yeah, I'm not sure. If you have any ideas, how I can stop wasting all my ice for oxygen generation. And obviously I know I could properly turn these into actual airlocks that are only open and close, or open and close in a way that they don't waste a lot of oxygen. But I mean I have enough oxygen in this atmosphere, so this is not really necessary. I just want to use the oxygen from the tank, and I want the tank to refill from the outside air vent instead of using ice. Build 3D printer. So we've partially done this. We built built frame, and we built the guides, and we've built the motors. What we'll still need to do is we'll need to build the welders, and then we'll need to add stepping function to z-axis and add automation blocks so that when the horizontal axis completes one pass, the z-axis automatically moves up, and then the horizontal axis returns and moves up and returns and moves up and returns. Because these are subgrids that are not connected to each other, it makes it actually a little bit more tricky to do that. But I have some ideas how to address that. So I think it's going to be pretty cool. And then print something. Profit. Oh, and I forgot. We built a welder ship. That's awesome. I think we've done a lot of the heavy lifting this episode. Next episode, we'll kind of like apply the finishing touches and turn the 3D printer into something that's actually usable, and we'll give it a shot and put our first sprint through it. So thanks a lot for watching. If you enjoyed this video, please make sure to subscribe. If you enjoyed this video, please make sure to give it a thumbs up. And if you want to see more like this, make sure to subscribe. I upload Space Engineers videos twice a week, and there's lots of other stuff to explore on the channel. And if you know somebody who would like this video as well, please share it with them. It's the best way to help the channel grow. Other than that, see you guys next time when we will finish the 3D printer.